I'm Jen Ravasia. I'm a film and media studies major and a comp sci minor here at Tufts University. Graduating this year, 2020.
I'm Dan Satlin. I'm a senior here. I'm a violinist, and I'm a computer scientist here at Tufts.
My name is Michael Eve. I'm a junior, currently studying computer engineering here at Tufts. I'm graduating next year.
It's a hand-strapped laser harp.
This circuit board that we originally prototyped on a smaller or larger breadboard, and then basically transferred and soldered over everything from an original do-it-yourself laser harp kit that we basically inspired a lot of the concepts from.
In addition to having 8 LDR photo sensors along the top, we also have 2 buttons along the sides. They're just sort of push buttons to lower or raise the pitch of the instrument, and a 3-axis accelerometer, though we are only using 2 of the axes on it.
There's 3 scales, so basically when it's facing all the way down, it's a like an augmented scale. Facing like this is a minor scale, and facing up is a major scale. And then with the 2 buttons, if you press like the up button once, it'll increase by just a half step, same with the down button, but if you double press it, then it'll go up by an octave. And we do have limits so that you can't get excessively high or excessively low. For this axis, which is the x-axis, so basically when twisting this way, we have it set so that our program will increase the filter frequency. It's going to increase that, and then going this way, it will increase the LFO, which is set also to the filter frequency, and that's going to increase the amount.
Notes are triggered by detecting changes in light over these photosensors. As it reaches a specific threshold determined by we only had a specific number of these LEDs, so this one gets its own special little function to determine its threshold. But if the light threshold ever drops below 77 or below 10, then it triggers a note. If it ever goes above that threshold again, the note stops.
Right. When you close off access to ambient lighting for one of the sensors, that's going to trigger a note.
The DIY kit came with, its own specific microchip, as well as this little, bridge. It only had 7 of the lasers and photocells.
And basically we'd have lasers shoot straight down along the side, and you'd put your finger and break the laser, and it would activate. We basically kind of tried to apply the same idea through Arduino, and that basically made it so not only could the instrument be played polyphonically, but we were able to kind of move it around as well, where
we were able to use something better than a tiny little beeper speaker on it.
And it wasn't just limited to the power source connected to the board itself.
We got to add an extra sensor, which meant that we finally had a full scale of 8 rather than
just 7 notes.
Where did you get the extra sensor?
From a second DIY kit. The LEDs are mostly for people who are either watching the instrument or for the player to know what notes are being triggered. It's more cosmetic than anything else, but it's helpful in the playing of the instrument so that people who are watching it can understand what's happening, even from a distance. Overall, it's working.
So at the scale, so I can increase the octave, increase by half step, so that was actually down, so. double click, it'll go up by an octave. And that's going down chromatically. And then if I twist, it's going to increase the filter amount. And then back in center, it's not going to trigger any special effects in the synth, but then twisting the other way is going to increase the LFO. This is major scale. And then when you, so that's when you're at the utmost position. When you go to the middle position, you get a minor scale. So then, and then we also have an augmented scale just for a little extra spice. Minor, major 7 there. The max patch is getting a binary piece of information from each of the 8 sensors that we have, and so if light is covered on one of the sensors, that's going to trigger a note on for that given note. We set the duration to be very long, and then I created a little function so that different notes can be released at different times. We have a little bit of smoothing that goes on in the accelerometer, just so that, and when you're like at like flat position, like even if you go a little bit to the left and a little to the right, it's not going to trigger until it passes a threshold. Whenever you press once, it's always going to go up that half step, and then if it receives another button press within a certain time window, then it's going to go up by a seventh. If I play like 2 notes and then I press it, then they're not going to change, but like any additional notes.
All of the notes pressed after the changing of the buttons will play.
Yeah.
Change the.
So you can get creative with that by like holding notes down and then changing the bass notes and then playing additional notes that aren't in that scale whatsoever. When it works, it's actually very cool. Like there's a lot of flexibility and freedom and like creative potential with this instrument, given the parameters that we chose to use. It's just when it doesn't work, it's just a bunch of random notes playing, which is noise, but it's not the noise that you want.